Okay, welcome to this tutorial, and we're gonna be solving this question here. The question reads, approximate the change in the hypotenuse of a right triangle of length 60 millimeters and 80 millimeters. So you have the 60 and 80 millimeter legs. When the shorter leg is lengthened, meaning it is increased by 2.5 millimeters, and the longer side is shortened, meaning it's reduced by 1.25 millimeters. So how do we approximate this? So first of all, to just get a picture, they've said this is a right angle triangle. So if I say this is my right angle triangle like this with, so they've given us they're saying the legs are 60 and 80. So the way they've given them as meaning x comma what, x comma y. So meaning the one the one that is the longer one is the what is the 80. That's the longer one, and the one which is the shorter one is the what, is the 60. So the longer one, as they are saying here, 60, as you can see, 60 here is shorter than the what, than the 80. So in the x-axis you have a what, you have a 60 here, then in the y-axis you have what, you have 80 there. Then they're telling you that these are the legs that are being used to what, to approximate. So I want us to approximate the change in the what, in the hypotenuse. And of course we know the hypotenuse is the longest side there. So now the hypotenuse, using Pythagoras' theorem, we know that the hypotenuse of these 2 points, meaning x comma y, is going to be equal to just the square them and add them. You square these terms and add them by the Pythagoras' theorem. I get that this is what I have. So now, where of course I know that uh, the x is the what, the shorter side, and then the y is the what, is the longer side. As you can see that this here, the y is the longer side, and then the x is the what, is the shorter side. So now we're going to use total differential for what, for h, for us to be able to what, to approximate the change in what, the change in h. So the change, since they're saying approximate the change in the hypotenuse, so the change, let's say change in hypotenuse, this here we use total differential, which is just going to be dh like this. So dh, what is it given by? So this is given by the formula, of course. You get partial of h, then with respect to what, to x, then this multiplied by dx, plus the partial of h over partial of y, then what, dy like this. So this here is what I'm going to use. So first of all, I must find this partial of h with respect to what, to x. So my h has been given or defined as here, you can see that there. So to differentiate this, I'm just, this here can be written as x squared plus y squared like this to the power half. Differentiate this here, I get, drop the power, I get 1 over what, 1 over 2. Then I have x squared plus the y squared to the negative half, because I reduce the power there by what, by 1. Then I am doing partial of x, so meaning that I differentiate the x squared, I'll have 2x here. Then writing this up nicely, this could go down, and then I write it as a power, as a square root. So this will be square root of x squared plus the y squared, then here multiplied by the what, 2x here. And what is this going to be? My 2, this 2 and that 2 there are going to divide, then I have x over the square root of x squared plus y squared is what I'm going to get here. Similarly, I'm going to do the same thing for the y. So for the y, you do the similar thing, and well, let me erase this and I write it again. So we found partial of h, partial of x is just equal to x over the square root of x squared plus y squared. So when I do the similar thing for y, I just end up with this going to be over y, then I have square root of x squared plus the y squared is what I'm going to have for y. So now the initial leg length. So the initial leg length, so let me erase this part here. So okay, let me erase everything else. We'll come back to that. So now the initial leg length that we have, of course, is x at 60 millimeters. Then you have what? You have the y at 80 millimeters. This is what we've been given. So replacing this into the function, or yeah, the function for the hypotenuse, which we wrote earlier, is just going to be 60 squared plus 80 squared, and this here is just going to give us 3,600 there. Then plus you have there, this will be 6,400, like that. You add the two, you get a 10,000, like that. And this here, uh, just the square root of 10,000 is just 100, so 100 millimeters, like that. So 100 millimeters is what is my initial hypotenuse, which I have. So that's the initial hypotenuse. But now look at how the question is phrased. They're telling us when the shorter leg is lengthened. So when now we need to find the change in what? The change in this shorter leg, and this what? And this longer leg. Now look at the change which we denote dx is the change. So the change now for x, they're telling us that the shorter leg is what? Is lengthened, meaning it is increased, meaning the change is what? Has been is 2.5. Now it has been increased. Then now you see that dy now for the y, they're telling us that the length of the longer leg has been shortened, meaning it's what? It's going to be a negative there, because you're shortening it there, so it's going to be negative 2.25. So for the shorter leg has been lengthened. The longer leg has been what? Has been reduced, or has been made what? Has been made short. So this is what is happening there. Now we bring back or go back to the change in x, to the change in h formula, which we earlier had written as partial of h over partial of x, with then multiplied by dx, plus the partial of h over partial of y, then multiplied by dy. Now what is this going to give me? So I'm going to replace the first one there. For x, I got my initial point. I have that my x is 60, and remember we had something like x over x squared plus y squared. So my x is 60, I replace my x there. Then down there I'm going to have square root of 60 squared plus 80 what? Squared. Multiplying by my dx is just 2.5 there, plus partial of h with respect to y. So there we had similar as well, y over square root of x squared plus the y squared. What do we get? We get 80 there on top. Then we have down there, we have 60 squared plus what? 80 squared, multiplied by the negative 1.2 what? 25. So negative 1.25. We erase this here. Where does this take us then? So we see that this is going to give us that my dh, my change, that is the change in the hypotenuse, the dh there. So you have that. Down there we evaluated this to be what? To be 100. So you have 100 there. Then you have 2 multiplied by 2.5 plus 80 over what? 100, then multiplied by negative 1.2 what? To 5. Then this here is just going to be, I divide the 100 into the 60, I get 0.6 here. Then I multiply this by the 2.5 there, plus then the other one is just going to be 0.8. Then I multiply by the negative 1.25 here. The next is plug and chug. Just have your calculator with you, and this is going to be easy. So you are multiplying for the first one. So the first one you have 0.6, then you multiply this by 2.5, then you have this will give you a 1.5. Then the other one you have 0.8, then you're multiplying that by negative 1.25, and that there gives you negative this here will give you negative 1. So subtracting the two, you just get that the change in the hypotenuse of this right angle triangle is just going to be 0.5 millimeters, like that. And this is how you approximate that change in the hypotenuse of a right angled triangle. Well, if you are new, remember to hit the subscribe button, and we'll see you in the next one.